You're listening to JS Party, a weekly celebration of JavaScript and the web. Find us on the web at jsparty.fm, on the Fediverse at jsparty, at changelog.social, and of course, wherever you get your podcasts, just search for JS Party, you'll find us. Thanks to our partners at Fly. Launch your app near your users for peak performance. Fly makes it easy. Learn more at fly.io. Okay, hey, it's party time, y'all.
What's up, friends and party people? I'm here with my good friend over at Speakeasy, founding engineer George Hadar. Speakeasy is the complete platform for great API developer experience. They help you produce SDKs, Terraform providers, docs, and more. George, take me on a journey through this process. Help me understand exactly what it takes to generate an SDK for an API at the quality level required for good user experience, good dev experience.
The reality is the larger your API becomes, the more you want to support users that want to use your API. And to do that, your instinct will be to ship a library, a package, and what we've been calling an SDK. There's a lot of effort involved in taking an API that lives in the world and creating a piece of software that can talk to that API. Building SDKs by hand is a significant investment, and a lot of large companies might pour a lot of money into that effort to create something that's like approaches good developer experience. And then another group of, a more growing group of companies will rely on tooling like code generators. And so they're very interested in, like, once you make the decision to use a code generator, you're kind of forfeiting some of your own opinions and what you think a good developer experience is, because you're going to delegate that to a code generator to give you an SDK that you think users will enjoy using.
Okay, so paint a picture. What's a good next step? What can people expect when they go to speakeasyapi.dev?
If you're coming across Speakeasy today and you want to use it, you will go through the onboarding flow, and at some point you're going to give us an open API document. That's your description of your API, and we're going to take that document and turn it into an SDK of your choice. You're going to get to pick which language is your first language. That's the one you'll get for free. And at that point, you can publish that package for the world to use. That's going to be yours. It's you get to license that however you want, and then carry on from there. The way you iterate now is you keep changing your open API document. So as you develop your backend, you're going to produce alongside that the open API document with any updates over time and evolve that. And as you're evolving that, we're generating the SDKs and publishing them for you. And that also includes rich documentation that goes with them. So we're asking you to put a lot of effort just into describing your API, and we're going to do a lot of the heavy lifting that follows from that.
Okay, so as George mentioned, go to speakeasyapi.dev. You get your first SDK for free. So cool. Once again, speakeasyapi.dev.
JS Party Animals. I am your internet friend, Jared, and I am joined today by Philip Burkhardt. Philip, welcome to the show.
Yeah, thanks for having me. I'm very excited to chat.
Happy to have you, man. Happy to have you. So shout out to listener Brian Zellup for requesting to have Philip on the show. Philip is the author of stdlib.io, the standard library for JavaScript, and a real live data scientist, right? Aren't you a data scientist, Philip?
Yeah, that's my job title. I'm a bit of a jack of all trades. I've done a bunch of things, but I do have a PhD in statistics and data science. So that's my background, kind of working with data and drawing insights from data.
Excellent. So perhaps a first here on JS Party. You know, we just normally talk to pure JavaScript nerds, but now we have a hybrid, someone who likes JavaScript and likes statistics, analytics, data science as a thing. Like, it seems like data scientists were super hot like 5 years ago, and now they all had to rename themselves to either data engineer or data or AI engineer. Have you felt the pressure to retitle, even though you're doing the same thing?
To kind of rebrand and to do something different. I mean, I think it kind of points to an issue that just that a lot of data science projects really didn't deliver as much kind of in industry and the value that kind of was promised, right?
Right.
And maybe like in that maybe there is not as much demand as was anticipated just for like pure kind of data science roles. I mean, and that's not what I'm doing either. I think like a lot of the actual work that happens in companies and stuff is often like kind of the more like what people call data engineering. It's like ETL, extract, transform, load, right? Kind of that's the acronym. And like really like how do you get the data into the right format to make it amenable to draw insights from it or like to work with it. And that's like what's kind of much more, I think, the daily works like that people do that work with data predominantly. And like the actual like what people would say is data science, maybe like just coming up with a statistical model to do predictions or something like that. That's really just a tiny fraction of the work that people in such positions do, because often it's like the main challenge is get the right data, make sure the data is of good quality, doesn't have any hidden issues and stuff like that, and that can easily bite you, right? It happened many times to
yes.
me. Yeah.
A lot of the work, it sounds, of data science. I know this by proxy because I produce the Practical AI podcast, and Daniel Whitenack on that show, one of our hosts, is a data scientist. Now, of course, he is now a founder of an AI-related startup, as most data scientists are at this point.
Yeah, I mean that's the other thing, right? The change to the rise of AI that happened now in the last that craze, right? Like and there's a lot of value in that. I mean, but it's also probably at some point there will be a adjustment of expectations. It's at least not the magic box yet that people expect it to be.
Yes, the magic box has some magic tricks, but they're not quite as magical as we hope they are, at least at this particular phase in the cycle. You know, one of the promises I've heard of LLMs is their ability to, maybe clean up the data for us or help us clean up the data. I don't know about labeling, but even just like, paste in a dirty CSV and tell it, hey, can you make this better? Is that a real trick it can do, or is that just people talking?
I mean, like you can certainly ask LLMs to, right, like prompt them to give you generate or do a cleanup. Whether it just introduces other errors, right, or like sometimes like it really depends. I think for some things it is really useful. I think for like if you have unstructured data, like text or like like and you want to where it's not very easy to write a deterministic program to maybe put it into a structured format like JSON, like you can easily do that, right? Just give an LLM a text and then like ask it to put it into a structured format, or like give it a website and like to just scrape it easily like that, just like and I think for those two, I mean that like where it's like a one-off thing where it's like like you don't need to have a complex, write a complex AST parser thing that tries to kind of extract all the relevant information like deterministically, and that's probably more robust, right? But often, it is more robust, but often that might be just too much work, and like it's like
right,
and like you can just use an LLM as a crutch to get to something. So like, if it works, it works. Like, I think there's some foot guns there too, right? But,
yeah, there are, and I've done some scrubbing and normalizing and all that kind of stuff. I've been around long enough to have data sets that come to me and I'm like, oh, this is a mess, right? And I just write the code that does it, but it takes a while and it's toil. And the thing about it is it's almost always throwaway code. Unless you're going to continually get like bad data from the same source and you're going to rerun that over and over again. A lot of times the work is like, well, I got to clean up this data set and then I'm just going to throw away all my tools that I made because they were ad hoc. And so if you can get 80, 90% of the way there by saying, by spending 30 seconds versus 4 hours, maybe you can spend 30 minutes on the resulting data set. And since it's all probably throwaway at the end of the day anyways, like you said, if it gets the job done, why not use it, right?
Yeah, that's, like usually I try to be pragmatic and think, like not to be too, like ideological about things. Like there are uses for things, and some tools are good at, certain jobs, whereas at others. And like for me, like LLMs right now at least are like a super exciting like technological advancement that does a lot of things.
Yeah.
But in the end, like it's not, like I don't know. We will see what happens, but whether the AI apocalypse is upon us.
Right. It is not the silver bullet that some people claim it to be. Okay, so let's moving on from there. Of course, this is the world of science and math and data that you live in, and so it makes sense to talk about it. But we're here today specifically to talk about your standard library project, which lives, like I said, at stdlib.io. The mission of this, it says, is a future in which the web is a preferred environment for numerical computation. So that's the reason why you built it. Can you tell us a little bit of the backstory, how it started, why it started, when it started, all that?
Yeah, for sure. I'm going to do that. And just to like correct the record a little, it's not my project necessarily. Like I started together with Ethan Weens, who's like a data scientist from San Francisco.
Okay.
And like we started this we have been working together now for 10, 11 years, so a long time really. And we started originally with a prior project and then like officially came into being in 2016. So
okay,
but I can give you a bit of a backstory maybe.
Please do, yeah.
And like how I really got into JavaScript and got very excited about the web as a platform and then had basically this challenge for myself. Okay, how can I, combine these two different things that I really like? So like I really want to do my academic work at the time but at the same time really like kind of got really into web development, kind of just building web applications. But I think the genesis, I mean, it is tied in some way to Node.js. I wasn't there at the super early stages when Ryan Dahl, that's like did Node, but then like there was this community, right, like that evolved once like I succeeded at NPM and the package manager, and like the people started like writing all kinds of packages, right, for the JavaScript ecosystem. And I think that wasn't there before. And it also like unlocked thinking about JavaScript not just as this toy language of the web browser, right? It's not this language that just is used for interactivity on websites, right? But you could think suddenly, okay, it can power web server, but it can also be like in a terminal if you need to do something, right? You can just use it. And so that's kind of in the background there. And I was like, after my bachelor's, I didn't really knew what to do. I did a bachelor's in economics. I didn't really like it. So I pivoted, so to speak, to statistics. And I did a lot of R programming. That's kind of the preferred language for like statisticians. And it has some nice benefits, but it's also has some downsides, as all things do.
Right.
And but I then did my master's. And while doing that, we were working on a project to kind of model the political or like the sentiment around different political topics on the platform, I guess now X, formerly Twitter, right? And we did a scraper to scrape newspaper articles from all kinds of sources. And then we extracted that information, and I used MongoDB as a document store. And that's like, has a JavaScript REPL, right? Like environment to kind of interact with it. And so that was what I was doing, this trying to kind of do topic modeling, which is like kind of probabilistically modeling these topics, and we added like a time dimension so that you can see how do they emerge over time, and then maybe also collapse again if like the news cycle is very, very short-lived, right? There's like a few topics that get blow up and then they suddenly like disappear again. So and while I was doing this, I needed to do some calculations, and I was already using Mongo. I had to use JavaScript kind of to interact with the Mongo REPL. I also had to do this scraping, and for the scraping at the time, now it has there's the Tidyverse and Hadley Wickham, like RStudio and RPosit. That whole ecosystem wasn't really there at the time. Like it was very in its early stages as well. So like now it's very grown and there's a lot there. But at the time it was just like, like walking a DOM tree in your and like extracting content from a website you couldn't do in R. So I used like Think.js DOM or Cheerio, and so like and now in my job now at Socket, like Eli and Shira is like my co-worker. So like it's kind of interesting. The world is small. You always end up with like crossing paths again.
That's pretty cool, right? Meeting people. I love it. I love it when you just use something for a long time and you just kind of like remotely admire its creator, but maybe never interact with them. And then all of a sudden you're like, oh, wow.
Yeah, and you never even meet, maybe, right? And that's kind of how open source works, right? So like people just put their things out there and then they take a life of their own at some point, hopefully.
Yeah, hopefully. Or they die on the vine. But, not everything lives, It's part of the circle of life. So, did you say Ethan? Was that your partner on this?
Yeah, Ethan Weens is This is kind of my collaborator on that. And we have now, the project has grown. So like, it's like, I think we are almost at 100 contributors now in total. And we have, now this summer we got accepted into Google Summer of Code for the first time.
Oh, so cool.
Like for super talented students working on different projects. I can touch base on that later maybe. But yeah, so it is really like a collaborative effort. Just want to highlight that, right? It's not like and that's what we want. I mean, we really hope to build a community of people and and people who are really engaged and like want to push this project forward, because it's like, it cannot really be done by a few people. Like it's too ambitious in some ways. But yeah, I mean, like that's kind of maybe some learning. Like this was like 2012 when we started this, right? So like when I started getting into Node and then like that I met Ethan like through GitHub. So I think he came across one of my repos and like so seeing I did some numerical things. And then he wrote me an email, and and there's actually one other funny story there, like because he hired me for the summer. I was like I wanted to do Google Summer of Code back in the day, because it was like I was when you're doing a PhD, you're like usually you get a 9-month salary, and like during that time you do your research and maybe you have to teach or like do some other work for it. But then maybe there are grants to pay you for the summer, or you can also teach in the summer, or you can do your own. But at the time I wanted to spend the summers in Germany, so I was trying to figure something out, and I was actually like, now again another coworker of mine now, Mikola Lysenko, who did a lot of very popular packages in kind of numerical computing, JavaScript, like the NDOA, kind of multi-dimensional array one, which is used in tons of places, and Plotly and other packages. So he would have been my mentor for this Google Summer of Code project, which was about like compiling using Emscripten back in the day, like to compile like C libraries for linear algebra to JavaScript, Emscripten. And that didn't happen. So it didn't happen, and then like this fell through because we were trying to do it through the jQuery Foundation. You remember jQuery?
Oh, yeah.
That was a thing.
I got some gray hairs over here. I know jQuery Foundation. I was out.
Yeah. So that is like when jQuery was like, I mean, probably still, I don't know how many websites still have it, use it, right? Probably still
more than we think.
More than one would think.
Yeah.
Right? Yeah, that's what I would think. But yeah, so then like I ended up like just hiring me for the summer to work together with him, and that kind of sparked like really like a long time collaboration. And we have it is a long road, and you see like there's always more to do, and it's Rome wasn't built in a day, right?
Right. Well, JavaScript was in 10 days, but one of the things that happens when you have a language primarily in a browser is you have a hard time expanding the breadth of the language. And so one of JavaScript's longtime downfalls has been a lack of any sort of standard library. I mean, most languages have one. Some are better than others. Some get old and crufty. Other people maintain theirs. And JavaScript, prior to Node, there just wasn't much there. And like you said, Node busted it out of browsers, gave people a reason to kind of take it more seriously as a language. And one of the things that serious languages have is standard libraries, right? Like a set of tools that aren't part of the core language but are attached to it and allow you to do all kinds of stuff that are common. Now, your project obviously is a third-party thing. You're not attached to the JavaScript language or the ECMAScript language. You are a standard library that is a package that's installable. But how did you build it out? What did you decide to build? I mean, there's so much stuff in there at this point. It seems like it was focused on maybe math at first, or maybe now it's focused on math and numerical computing, but there's so many like, utility functions and stuff that it's beyond that, but that seems to be the focus.
Yeah, that's like you get that question quite a bit. I mean, like, as you said, right, JavaScript historically didn't have like a standard library, right, like comparable to other language ecosystems. So, and that kind of limited significantly what was possible. And you also mentioned the challenge, right, that basically the language being in the web browser and having that unique position, right, that it's kind of means that it also evolves at a different pace than other languages. So it has to go like the TC39, there's committees, right, like which need to have changes. And so like it's very much like maybe things are changing now a bit because there are all these JavaScript runtimes now, right? Like there's Bun, which is just like forging ahead and just doing stuff, right, and forcing the hand of many other players there. And so there's this proliferation of like now other JavaScript runtimes and like with Dino as well, and like TypeScript like kind of like being like getting full support. So I think maybe things have changed a little, but like back in the day when we started, we were just thinking, All right, so like there's definitely this lack of a standard library in JavaScript, and we needed we really wanted to provide like kind of a really like a rigorous and high quality set of tools and functions, and also like have everything in a way that's fully documented, where we can have like we strive to have 100% code coverage. Everything's fully documented and like everything's coherent, and so we really wanted to do something where we do not have to depend on external kind of tooling or dependencies that is where you end up in a situation that, I mean, now I'm working at Socket, so we do supply chain security for companies. So like kind of there's always, when you depend on third-party code, right, that's a risk. It's just a risk because things can break, things can change, right? Like, and of course it's also like the biggest unlock for like productivity, right? Because you can just draw on all the stand on the shoulders of giants and prior work that people have done. But for us, it was really like, okay, we needed certain functionality, and it was just not there. And so we were just like, okay, like we will kind of build this out on our own and like really ensure, okay, this is a high quality and code that we can depend on for the future. And I would say like that, like this focus certainly, I think in my mind at least, has shifted to like, okay, we really want to provide that numerical and statistical computing infrastructure, because like there is, at least I think the sentiment has shifted in some sense, because now with all the language features that in year 6, starting with year 6, right, like all the additions to JavaScript, people are just less complaining about the lack of tooling and that is baked into the standard library. And there has been more standardization about kind of what the web APIs and what's available, I think, as well. So I don't think that's like our like main selling point, but we do offer more than just numerical and statistical computing. That is certainly true. And that's why kind of where if you want to do text processing, or like you have some other like tasks with natural language processing, or like just general utilities like working with arrays, working with multi-dimensional arrays specifically, right, which is like a fundamental building block you need for any kind of numerical statistical work. That's all kind of part of the library, and that's like part of these things are never gonna come to JavaScript in all likelihood either. So like that's because like it's just like the language, given the kind of environment it lives in, more likely not that support for those things in the future.
This is a changelog news break. Everything about Chrome's new Window.ai feature. The Chrome team recently announced they're adding built-in AI, a Gemini Nano AI model right inside your browser. It's currently only on Canary and hidden behind some flags, but you can play with it right now if you want to. From the article, quote, "The new Chrome.ai API is a game changer because it runs locally and completely offline. This feature is set to become a web browser standard, which, in the future, will enable developers to use AI models that don't rely on a third-party API." End quote. That part about this feature is set to become a web browser standard, that's pure conjecture, best I can tell. However, Google did mention standardization once in their overview, so it's at least on the table. Local and offline language models are coming soon to Apple devices, so the web will have to eventually follow suit to stay competitive. You just heard one of our 5 top stories from Monday's Changelog News. Subscribe to the podcast to get all of the week's top stories and pop your email address in at changelog.com/news to also receive our free companion email with even more developer news worth your attention. Once again, that's changelog.com/news. So as of the GitHub README, 150 plus special math functions, a bunch of probability distributions. There's a lot in there for data viz, and then just 200 plus general utilities. If you're doing data transformation, functional programming, that's kind of the stuff where as the platform has gotten better, some of that stuff has just gotten less useful because it's built right in, and that's great. And there's a lot of stuff in there that's probably not still built in, but there's a lot of functional abilities inside JavaScript, the language.
But maybe sometimes you want like a functional API, for example, like a lot of things in JavaScript are hanging off of the the prototypes,
right?
Like, and sometimes so there's still value, even if the utilities, I would say that are now part of the standard library, there's still good reasons to have those utilities, like just for documentation purposes. Because, for example, we do have a REPL environment where you can look at help pages, you can look at examples, and we really want to have a coherent kind of experience there, right? So it's not like you go into you work with the REPL and let's say you do some data transformation and you like plug elements from an array or something like that. Or you can write we just wanted to make sure that you can just call the help function on that and you would see the documentation for that specific function. And there's no discrepancy, like all functions have that basically. So it's a very uniform and design and puts an onus on us to make sure that that's all there. But we hope that in the end it is for the end user experience.
Do you know how many functions are in this entire library roughly?
Like you can look, we have one of the the goals of the product is to be fully decomposable, right? So one thing we decided early on is what we want to do differently than other projects, like say NumPy, SciPy, ecosystem Python, or it's really okay, every package can be independently consumed. It has defined all the resources are located in the package or specifically depend on other packages. So we have right now 3,000 something. I mean, we can you can look. We actually push a generated GitHub repository for each individual package in standardlib, and right now, if you go to the standardlib.js organization on GitHub, it has almost roughly 3,800 repositories or something like that. So it has grown quite a bit.
Okay, so do you do that so that they can be installed individually, or why are you doing that?
Yeah, so we do it for so you can actually go to npm and find any of the packages individually. I mean, you can also just install the whole library or a different namespace, organized in namespaces. So if you want all the statistics functions or you want all math special functions that are part of the library, those can be installed together. And that if you use a bunch of them, that's preferable. But if you just want to have a few, you can just install those individual packages. And we generate the GitHub. So both surface the code, so it's easy to browse the code. There's a change log there. You see what has changed for that specific package. It has information about we also generate bundles now for different for Dino or ESM. So ES modules, the library is still all ES5, so very old school, old style. But we generate bundles for ESM. We come in JS and get UMD bundles as well. So it's just to allow for different ways of consuming.
Yeah, no, that's great. That's great. That legacy, that old stuff just makes me think that you've gone through so many transitions probably from 2012 till now, roughly, as you built this thing out. Surely there's been some pain in that process, right?
I mean, as I mentioned, we have been very conservative in kind of not adopting kind of new language features. And
sure.
Again, that is a double-edged sword. It is actually more performant. I we try to be most idiomatic to C code, or if you write code like if it was C with loops and with instead of the functional map or filter and stuff like that, you usually write better performant code because you avoid the compilers can optimize it better and you avoid those multiple iterations, etc. So we really try to write performant code and also not be very not have variadic interfaces and functions. So because that prevents compiler optimization. So if you always know the arguments passed to this function have the same types, then that will be good for the JavaScript runtime to kind of compile the code efficiently. And that's kind of that was a conscious decision, and we didn't really we are not opposed. I mean, I think it's great how JavaScript has evolved and all the new capabilities, but and in the end, it doesn't matter right now. For an end user, if you use us, it doesn't really matter. You can use us, right? And whatever you do, if you write a React web application, if you write modern ESM, if you write TypeScript, we have TypeScript declarations that we ship for all packages as well. So they're all typed. So you will not really see it. And also the one main advantage probably you would have with ESM would be if you use import syntax. That you get tree shaking, but as I mentioned, the product is already fully decomposable and modular, so you can just install or require what you need, and you don't need to rely on tree shaking. So, but yeah, we will at some point. It's a big, but since there's so much, right, it is, as you said, it is a big pain. So we have still the var instead of constant let declarations in the readmes, and we don't want it necessarily because that people have moved on in some ways. And so it would be nice to change that, but it's just, it's a bit of a challenge. It's a big project, right?
Right, yeah, totally.
Yeah, maybe we can do some transformations with write some scripts to I don't think ask an LLM that will probably introduce subtle bugs, so you don't want to do that.
No, there are certain things that are more important. And then you'd also have to decide, should we use const or let everywhere? And, you and your team can probably argue about which ones you should use given specific nuanced contexts of 3,800 functions.
Yeah. There's a lot, so it would need to be decided. And we would actually need to look at the code. Where does it? But I mean, you could do that. Like you would probably do something like where we just use const for the require, like for the pack, right? Requires, and then for most things that might be reassigned, we just use default to that or something like that. I don't know.
Oh, that's way too reasonable, Philip. You have to argue about it more than that.
Yeah, it's I don't know why that is, but it seems like at least specifically in the JavaScript ecosystem, there's always a lot of heated debates, like a lot of I think other ecosystems seem calmer.
Yes, but I think the proper term is bike shedding, isn't it? I mean, heated debates about small things that don't matter all that much.
Yeah, you don't want to get bogged down and don't lose the big picture, right?
Yeah. Well, you got a lot of stuff to do. Are you guys still like building it out, or does it feel pretty much like we've covered the breadth that we want to cover and we're just maintaining?
Yeah, still. I mean, like, so as I said, I'm super excited. We have that we got into Google Summer of Code. We have some like great projects currently underway. Like that, we have like one Lisa contributor, Snail Shah, who's working on like basically supercharging our WEPL for like that has a lot of new features coming along there. And we like also have another project building out fully our like linear algebra kind of functionality with BLAS and LAPACK. So that's coming along, and also like we didn't have all of it now, but we will after this GSEC period. We will probably have like C implementations for all the math functions in the library as well. So you can use like with NetNode add-ons, really get performant. Like I mean, JavaScript itself is decently performant, right? But like you can get maybe up to 2x of C or something like. But if you like really need performance, right, you do like want to use the capabilities of like just, running it in a native add-on. So that will all come along. But there's still, I mean, I would say it was a bigger undertaking than initially envisioned, and like just because of the constraints we put on ourselves to be really like make sure things are fully documented, fully tested, are like that we can stand by a claim. Okay, this is high quality code that like you can depend on. That put a lot of onus on us, and like of course we could have moved faster probably otherwise, But it's always a trade-off. You need to decide what you want to do, but we are like coming along well, and we're very excited to have grown a decent contributor base of people who are like working on the project, and just hope that continues, and like definitely in it for the long term. So
yeah.
But,
well, you've proven that so far. You've been in a long time already, and why stop now? I guess maybe burnout would be the reason, but it just sounds like you have a decent team. So it's not just yourself. It's not just your partner in crime. There's other people working on it. I would like to take a chance at this potentially being too nerdy and too technical of a question, but can you explain how the decomposability works, like how it's architected so that everything can be decomposed and reflected? I'm sure it's very aware of itself in order to do all this stuff that you're doing, like breaking out separate packages and all this stuff that you're doing. How does that work? How is that built?
So I mean, first of all, like there's like the organization of how the library is authored, right? So basically we use the Node.js module resolution algorithm. So things are actually in the Node modules folder and like every package is its own kind of Node package, basically, like internally. So like, and then you need to make sure, okay, like if I'm writing my files, right, like I only require, like I don't do relative requires of files that are co-located in a package, right? So that's what we do. And like, or we have an explicit dependency, right? That gets where we import like a function or like whatever it is we need from a different package, but then that's explicitly loaded in the package, right? And then like when that, and then we have a whole tooling kind of pipe chain, like there's a lot of GitHub Actions workflows that analyze the code and make sure that, okay, which packages are used in there, right? So like then those auto-populate the package JSON files to have those in there. And then like that all gets, as I mentioned, like we publish we push to different repositories on GitHub. So we generate basically all these individual repositories and publish the packages from there. So it's basically like we have to publish like 3,000 packages, but we intentionally like, there's a bit of history there. Like when we started this, we started just writing different packages for like doing stuff. Like back in the day, it was called Compute.io. So we had some different packages there, and we manually had to do all that, right? Like, okay, we want to publish a patch to that package. Okay, you run the npm publish command, and if you make, but then the problem becomes again if you need to make an edit across all packages or something like that, because suddenly you have a bit of a problem because you have 300 repositories and now there's a lot of manual labor involved just to make one change. So that caused us to move to this mono repo and like just say, okay, we're going to have everything in the standard lib kind of development repo, do all things there, and then have like just a lot of tooling and workflows that handle the independent publishing and I don't know how many of the prolific maintainer, I don't know, like Cinder Sohos or someone like who's like has to maintain so many thousands, like hundreds of packages. Right? How do they do it without?
Right.
I bet they like here like come also up with their own automation and solutions to this because like it's just a big challenge actually to if you have many packages to maintain and make sure that like you can push a fix out if needed, etc.
Yeah, I'm sure it's a huge challenge. So if somebody wanted to dig into that architecture and maybe use it for their own stuff, is the place to look is probably the GitHub Actions of the mono repo? Is that where most of that?
Yeah, that's where most of our tooling is. We also have like make certain make recipes that are in we have a tools folder that contains a lot of tooling in the library. So, but you can check out the standardlib.js GitHub organization and the main repo there is standardlib. And that has, under lib node modules are where all the packages are organized. And that's just uses CommonJS require. And but then those, for example, if we want to release ESM, we need to do the code transformations to actually transform that too. Because but right now at least we still only publish CommonJS to NPM. That's also like there's the whole debate, right? You do the dual exports, and like have ship multiple bundles and all that kind of stuff. And it's actually quite complicated, right? I think the whole transition from CommonJS to ESM and Node proved a bit more complicated than people had hoped. But it's where we are.
Yeah. Is your stance just to wait it out? Is that what you're doing?
That's kind of where we are right now. Wait it out until it's like fully there, and like because right now, as I said, I don't think you can use us just fine in a project that uses ESM, and you wouldn't gain much if it was like ES modules. But,
right.
But yeah, and we offer those other, like we have ESM bundles now we generate as well, and we will try to keep up with things, and like if like as things progress, we might ship more, or like we might change how we publish our individual composed modules, but we will see. I mean, that's like I think it's certainly not something where we feel like we have to be follow the latest trend immediately. Like I think already JavaScript suffers a lot from like there's so many, right? Like every year is a new web framework and whatever. So like things that you have to deal with and like learn new stuff. So it's really like try to be backward compatible mostly and try to make sure that if you want to depend on us, you can.
Yeah, I mean that's what people want from a standard library project, right? They want dependable, maybe even a little bit boring, well thought out, well documented, high quality code, but bleeding edge out of your standard library, those two things are kind of at odds with each other. So I think you're taking the right stance there. I'm on the GitHub page, 360 open issues, 88 open pull requests. So much has gone into this, almost 50,000 commits. I don't know if you know that. You're making it close to 50,000. Do you guys track these things?
Yeah, that will be like a new milestone once we've reached that. I mean, and most of those, we have a few things that are automated, but but not the majority is actually like written right by hand.
So huge project, tons of effort has gone into it. And then clearly a lot of effort's going to continue to go into it, especially you're getting things like Google Summer of Code, which should be an excellent boost to what you all are working on. How do you prioritize? How do you pick what to work on? Who triages issues? I mean, this seems like a full-time job for some folks, and I know you have a full-time job. So
yeah, so that's certainly a challenge, right? So like luckily like Ethan has support from his employer Quantsite to kind of work on standardlib, so there's buy-in there, and I'm like using a lot of my free time to invest in this, but I'm also luckily working at a company where it's like big believers in open source. A lot of people there, right? Like when our CEO for us, Luca DJ, is a big name in open source. I did WebTorrent and like Standard.js and all kinds of other things. And now founded Socket. So I'm really grateful for be working in an environment where, like open source is a thing and people support. But like, I mean, we just like, of course, any open source project can only really work with the community and like through maintainers. And we're always, looking for new folk who want to join and help us out. So like, that's like, there's tons of things to do, be it on the kind of writing implementations, like doing documentation stuff, like doing more like we need to get better at like kind of putting the word out there and like making, because we've come a long way, but we still, haven't really been. So like, I was very grateful for that opportunity to kind of promote the project, come on and have that conversation with you, and but those are all things, right, that should be done, and so like always exciting if new people kind of come on board. We do hope, of course, that like also like long term we'll find more like corporate backing, right, and like and this has become some like a thing that is dependent on which is. I mean, it's heavily used, but it's like we obviously want to be dependent on it by major corporations, etc., and like in the libraries, and then kind of get buy-in through that. And but it's like the reality there is just like, I mean, in the grand scheme of things, like JavaScript is still a nascent kind of environment for like numerical kind of statistical computing things. So most people just by default would opt for like, let's say, Python, right? And that's like that crossing that chasm and like just making sure that, okay, we have that everything is there that people would expect out of the box, right? I think that will be a huge unlock, because then there's no reason why you cannot use JavaScript to do most of the things that people right now use Python for example, in the kind of data science, statistics, ML.
Yeah, it seems like are there frameworks and toolkits that would be, slightly above you and using you? I'm thinking like, and I've never even looked at TensorFlow.js, but I know like that might be a thing where it's like, okay, it's TensorFlow in JavaScript. I assume they have some numerical computing going on in there. Like, are there projects that people are using or could be using to do this stuff that are similar to like PyTorch and that kind of thing?
Yeah, I mean, like that's certainly something we will also explore. So we have, I mean, like I don't think right now, at least in terms of libraries that would use us under the hood for I think. But we have, for example, we have been in talks with Joe Stajong from Math.js, and we're working with him to like potentially use like our multi-dimensional array implementations to power kind of Math.js going forward. So that's something we're actively exploring. And there's also, because like JavaScript is very fragmented, right? And there's like, so there's an opportunity to think about, okay, there are some libraries which are not really maintained anymore either. Like, for example, JStat is one of the earlier statistical libraries for JavaScript that got pretty popular. And yeah, Trevor Norris, who's like maintaining this, like I think would be very happy to hand off some of that work. And like, so we have been talking with him. Can we make sure that gets further improvements and updates if we kind of can provide some of the underlying foundational implementations for that? So I think that there's opportunity there to kind of standardize the ecosystem hopefully a little and make sure that there's not and of course we would need to prove that we provide the right building blocks, right, and that it's like that it's that you gain something from depending on us versus like just going out to roll your own. But I think that we can make that case because like we really made sure like everything is like numerically accurate. You can really depend on the implementation. You don't get wrong results and so that like it's hopefully a good foundation for numerical computing in JavaScript. Yeah. But that's also something we need to do more in the future.
Well, there's always more to do. Yeah, shout out to Quansight Labs for sponsoring and supporting. Of course, shout out to Feross and Socket. Listeners of JS Party know Socket and Feross very well because they're longtime friends. And of course, Socket also sponsors some of our work here at Changelog. So we thank them for that as well. In fact, Brian Zellup, when he wrote in asking us to have you on the pod, he even said that you're like extended JS Party family just by being a Socket employee. So lots of love going around. Would love to get more love onto this project. Do you have a GitHub sponsors? Is it easy? Or there's an open collective? How do people actually?
Yeah, there's an open collective. So if people want to sponsor us, I mean, we certainly welcome financial sponsorship as well. But also like if anyone is interested in just, joining to contribute to the project or just using it, right? We are very excited for, and always looking forward to that and talking to people. So, and we did also in our GitHub channel, which is linked from the repository. We right now have like office hours once a week. So
that's cool.
To drive to stop by, and if they just have questions for like how to start contributing, for example, they can do that. And I would just be very excited to see.
Very cool. What are some waypoints for folks who maybe aren't doing numerical computing, but they're app developers? Maybe they're using React, maybe they're building Express server-side apps. Like, what are some places where like I need this in my life and StandardLib has it? Are there specific tools that are more popular than others, just for, Jane and Joe developer?
Yeah, I mean, like, I think what we will see is that, like, right, like now things seem to be like coalescing around like full stack development with JavaScript, right? Maybe you have an Express server, or then you have like a MongoDB data store or something, and you use React for the front end, right? Or like maybe use TypeScript or pure JavaScript. But I think like we see more and more, right, this common language stack, which was one of the big draws for me for JavaScript. And once you have that, right, like and now you do want to share code across the client and the server, and maybe now you need to do some data manipulation, right? So then you could use some of the utilities we have in the library. If you need to do text transformations, we have a lot of things to working with strings and in a way like more advanced than what if you just use things out of the box. And we have, if you maybe you do need to do you want to display some statistics on your website or like something like that.
Yeah.
Maybe you do want to make that, don't have that work happen on the server. Like there's always like a trade-off. If you need to have like a server-side rendering for SEO purposes, right? Then okay, do all the work in the server to ship the final HTML to the client. But in many cases, maybe you don't want to do that. Maybe you have a web app that has like a dashboard with some graphs in it, and it has displays some statistics, or like has some numerical features in there. Like you can use some of the libraries that are packages that are part of StandardLib to do a statistical test to calculate the mean, median, or other numerical measures in a very efficient way, and then display that. And you can do these calculations like on the client side, and that like is something that like then you don't need a big either have a beefy server, or like if you do have a serverless setup, right? You don't risk of like getting charged a bunch because you do all these function calls in the cloud. So so that's kind of like where I think really like the main advantage also there is like for just being able to do all these computations on the client, right? So like if people want to have any of those needs, like and would like to do some of the things that you would find in Python or like in R, we hopefully have you covered. And if not, like like we try to prioritize things that our users want.
Sure. Very cool. Well, stdlib.io, of course, that links out to the GitHub. We'll have the links to all those things in our show notes for everybody. What else is going on? Coming down the pipeline, of course, Google Summer of Code will be huge, but do you have anything else burgeoning? You mentioned pre-show, there's a survey of some kind.
Yeah, so we do so if you go to standardlib.io/survey, and that's not live right now, but it will be shortly, we will have a little survey for people who are interested in statistical numerical computing and JavaScript, and kind of just to learn a bit about what kind of applications people are looking at, kind of what would they expect, just to get a general sense. And if anyone is interested and would fill that out, we'd be very grateful. And what else is coming down the pipe? We have, we have the kind of those Google Summer of Code is in full swing. And we have recently, we will focus on more kind of building fully out that linear algebra functionality, making sure that kind of finishing our automation story there as well, so that you can do, because we have, if you need to have all these functions then available to directly operate on multidimensional arrays, so like that you can do kind of really have all the building blocks you need if you want to do more advanced like machine learning or like other algorithms. That then once we have all those things in place, kind of unlocks a lot of other use cases down the road.
Awesome stuff. Well, Philip, thanks for taking the time out of your day to hang out with me and tell me all about this really cool, long-standing, and very feature-rich project, standard library for JavaScript and Node.js. And thank you again to Brian Zellup for requesting this episode. By the way, you can also request episodes to JS Party. Go to jsparty.fm/request. There you'll find a form where you can give us a tip. You can tell us a guest you want to have on, a topic. You can even select your JS Party panelists and hosts. Do that. We read them all. We make a lot of episodes based on your request because we want to serve you, our audience. We don't always turn every suggestion into an episode, but we read them all. And so you'll have our eyes in our ears, and perhaps you'll have a episode thank you to you happening soon as well. So that's all from me. On behalf of Philip Burkhart and the Standard Library Project, I'm Jared, and this is JS Party, and we'll talk to y'all on the next one. All right, that is JS Party for this week. Thanks, as always, for hanging out with us. I did confirm with Philip that their community survey is indeed live. So you can head to stdlib.io/survey and help the team gather insight into emerging use cases and to better understand pain points and gaps in the library. Once again, that's stdlib.io/survey. Responses are anonymous. Thanks again to our partners at Fly.io, to our Beat Freakin' residents, Breakmaster Cylinder, and to our friends at Sentry. Don't forget, code changelog saves you $100 off a Sentry team plan. Use it or lose it. Next up on the pod, K-Ball convenes an Ember.js roundtable. At least, that's what I think is happening. It hasn't been recorded yet, but there's a bunch of people on the calendar invite, and I know the Ember community shows up in force. Stay tuned for that one. We'll drop it into your podcast feed next week.